Hello everyone, I'm John Atkinson, and this is the Obfuscation situation, which seemed like a good idea for a talk title before I had to say it out loud. I'm a security data science person. I'm currently a data science lead for one of the larger US-based EDR vendors, and previously I worked as a head of security data science for one of the government departments down the road, and I've done some other stuff before that, of course. All the code used in this talk is on GitHub if people are interested, and yeah, let's begin. So, the message for this talk is basically, if you're a blue teamer and you want to share some information, handling that data and obfuscating it the way you want it to is really difficult. And sometimes as researchers or investigators, we have a reliance on this sort of data. But the fun part is, if you work in cybersecurity, the bad guys have this exact problem too. So this talk is about fundamentals. It's not about ML. It's not about AI magic. There's a tiny bit of stats, but I've covered it in bright colors, so it's fine. So, we're building a data set. We want to somehow remove some information so it's safe to share, either internally, externally, whoever you want to give it to. Our friends down the road, the ODI, the Open Data Institute, not so long ago published an article called Anonymizing Data in Times of Crisis. And this is the techie bit. You'll note it's step 4. Step 1 is ethical and legal considerations. So if you're considering doing this, basically step 1 is get help. Don't try and do this on your own, just with some data you've got. But yeah, there are some things we can do. We can either keep it. That's really obvious. We can suppress it and remove it, i.e. throw it away. We can generalize things, so remove some detail. Maybe you don't need to know my address exactly. Maybe it's fine that I live in Leeds or live in England. We can randomize. We'll show some examples of that in a minute where we add some noise. Or we can pseudonymize it, which from now on we're going to call adding fakery, because that's really hard to say. So, this is the boring techie bit to get it out of the way. So we've got a data set. We want to make it realistic looking, but not like the original data. So, originally we had a title, your Mr., your Mrs., your Ms., whatever. We're going to throw that away. We also have a first name and a last name. And what we're going to do is generate some new ones. But we're not just going to generate them randomly. Every John is going to be replaced by the same value. So if John goes to Chris or whatever, every John will become a Chris. Same for last names. Atkinsons will be called Thompsons or whatever. Gender, we're throwing away. PIN, we're throwing away. Darkest secret, we're basically throwing away the information, but instead we're just going to overwrite it with the same static string, which is the same as the completely removing it, but if you've got systems that are expecting that as an input, there's still something there and they won't break. Favorite color? Again, we're going to generate some colors. Phone numbers, we're going to generate legitimate looking phone numbers. Email, IPs, you get it. They're going to be private IPv4. And commonalities, we're going to pass straight through, because that's just the column I use to try and work out how things map together. So, we've done that. We've got our cast of Cluedo. And you'll see if you look at the blue bit, those highlighted phone numbers, they've been consistently replaced. If you look at the green IPs, they've been nicely replaced in green by different IPs. And yeah, looks like it's going okay. So maybe this is safe to share. There is a bit of weirdness though. So if you look at favorite colors, if you ask human what their favorite color is, they probably see red, green, blue. They probably don't say old lace unless they work for Dulux. And similarly, if your name is Ashley Sanderson, it's possible you have the email address williamskevin@example.net, but it's going to be unlikely, particularly if this is a work email rather than something that's likely to be shared. So even though we've started to sort of obfuscate and anonymize this data, we've already, even with really simple transformations, started to break relationships that we as humans might expect to be in there. And this can be a good thing or a bad thing, depending on whether you want to keep them in. And it depends on who you're giving this information to. This might be really bad if you're later trying to work out what the username or email address for a particular person might be based on the data. But of course, the bad guys have this problem too. So Tracy Kane here, who's very kindly sent me a spam email in French, which is a language I don't speak. It's a bit weird that they have the email address jbell@mdfcube.com. So this is just something that's inconsistent. It sticks out. Plus, the URL shortener and everything else that Google's decided that makes this spam. But it's another bit of a data point that's hard to manage unless you're really looking for it. So yeah, doing the substitution is actually quite easy. Consistency is hard, and it's really hard if you want to try and keep it consistent across different variables. Yeah, you can also go too real. So, dangerous defaults is a fun one. So, if you've got things of the form, maybe it's IDs, ABC, XYZ, there's the really fun example of a US wallet company that was very big, and to sell their wallets, they put in like a fake ID card. And they on there made up a social security number and just put it in. Unfortunately, that was a real person's social security number. And some people, because there were lots of people with wallets, would look in their wallet, see this printed name, and then use that as their own social security number. So the people that designed the wallets never expected this to be a problem, never really thought about it, but it did. And I think they ended up being sued. So that was a fun time for them, I'm sure, trying to explain that. Similarly, the library we're using here to do all these substitutions, it will run out of names eventually. There are far more names in the real world than will be in the list that it has to draw from. And relatedly, if we had kept titles in, your misses, etc., and hadn't thrown them away, if we'd replaced those, and if you had a big enough data set, say for the whole of the UK, you'd still be able to work out which were the misters originally, because it will always be the biggest group, assuming you've got a big enough sample size of that sort. So, yeah, you can leak information that way too. Randomizing things, this is a bit more of a subtle one than just replacing them. So, that's us at the red dot, more or less. Maybe we don't want to give our exact information. Maybe we want to lie slightly about exactly where we are. So maybe we can add a bit of randomization when we're giving our coordinates. And instead of being in this room, we're going to be having a nice walk down by the river. And this works great, as long as you do it once. If you start doing this again and again, because your GPS does it every 30 seconds or whatever, aggregation will completely unravel this, because you don't need to be a genius to work out the actual point, the real location, is the exact midpoint of all these additional events that have been generated. So this is one way you can detect spoofing. There are guides online to do this on your phone. But interestingly, the main use doesn't seem to be fraud, or that is a reason to do it. The main reason is actually to cheat at Pokemon Go. So there you go. Yeah, random is not undetectable. So, in fact, the opposite. So we're going to talk briefly about domain generation algorithms, which are a technique that malware uses to work out what its command and control domain is. So yeah, which of these looks more legit to you guys as humans? Is it goodhousekeeping.com, or is it this thing that I'm not going to try and pronounce? You don't need to be a malware analyst, but if given these two options and said, tell me which one of these is the WannaCry kill switch, yeah, you don't need to be a cyber professional to learn that. But that's interesting, because if we think about why we know that, even without knowing, it's interesting to think about how we would teach a computer the same logic that our brain is using to go, that's weird. So one way, it's a very simple way that you can do in some code very quickly, which is why I've chosen it, is to look at the combinations of letters in these domains. So if you've got Google, your bigrams, we're calling them, are 2 letters. So G-O, O-O, O-G, etc., etc. So what you can do is you can take the top million domains that are in use across the internet from this data set called the Majestic Million. You can do this analysis, work out the probabilities of how often they occur, and then when you get a new domain in, you can get the computer to score them based on the likelihood of each pair within that domain. And as you can see from the graph here, this works pretty well. So the Majestic Million of length 16 and the Emotet, which is a constantly recurring email campaign that sometimes uses DGA, you can separate the two, not perfectly, but quite nicely. And considering the code for this is really short, that's something you can teach machines to do that a human sort of knows through intuition, but might be hard to articulate. You probably wouldn't use that on its own. So the other thing you got to wonder about when sharing data is external aggregation. So yeah, that DGA thing's all very nice, but there will always be some overlap. So you can do what domain reputation services do, which is pile in a whole load of other data as well. So things from who is, information about who registered the domain, where it was registered, how long it's been live, any scanning that's gone on to work out what's been on that domain previously. And that's super powerful if you're trying to work out whether you should allow this connection out of your environment. But as defenders, this can, of course, also work against us. So OPM is the US Office of Personnel Management for the federal government. Basically, it's what manages all their staff. And Anthem was in fact still is, a US medical provider. These two were breached in 2015. And yes, it's bad that both these places were breached. Obviously, that's medical insurance information and staffing information. But the worry was also that if you combine these two things, different people in different parts of the US government are going to have different types of health insurance based on what they're doing. So that was the worry there. This was back in 2015. And yeah, just because you've curated your data set to be, consistent within itself, it's always worth thinking about what else it could be joined with that might unravel all of your good work. This is a bit of fun. So BDEP was a piece of malware that used domain generation. And the thing about domain generation is it looks really noisy because it tries all the different various combinations that are possible at that time, which looks quite noisy on the network. So what they decided to do was, instead of trying all these different combinations, what they do is connect to the European Central Bank, look at one of their rates, and then use that as the seed to know exactly what domain was valid for that day, which is quite clever. But of course, then the connection to the European Central Bank becomes the indicator if you're not the sort of organization that does that every 5 minutes. The other thing is your reliance on the library, in this case Faker, for whatever you're anonymizing. So, rather hilariously, the JavaScript Node version of this, the author decided one day he didn't want to do this anymore. And that was the end of the library. He just overwrote it with some swear words, I recall. And yeah, if that's part of your data sanitization pipeline and you don't catch that, that's going to be a problem. So like everything else, you're reliant on a huge stack of tools to, format the data the way you've expected and the way you want the output to be. So yeah, walking the balance, attackers have this problem. So there's your simple identifiers, your IOCs, your really well-known domains, your hashes on one end, and then random signals and detectable variants on the other side, where everything just looks a bit too weird and becomes detectable. So you've got to constantly balance, and you're constantly fighting against the blue team attempts to detect this. And the dataset curators have the exact same problem, but for a different reason. So you can give out your information with simple identifiers, you can give out the raw data if you really want to and you think it's safe. But that probably isn't what you want to do. There's probably things that can be misused in there. But if you go too far the other way, particularly if you don't know exactly what this information is going to be used for. If it's going into ML, you don't know what relationships you might be breaking by applying these transformations. So again, you can go too far the other way, you end up with a random signal, and you have no useful information for whoever you're giving this data to use. Practicalities. Collaboration is key. Number one, please get specialist advice. Don't just decide to share some data on your own. You will not have a fun time. But more practically, if you're going to share some data with someone, try and work out what they're trying to do and what exactly they need. This seems obvious, but often that's not the way it works. In particular, try and work out what patterns you do and don't want to persist, and if you can, try and either get rid of them or ensure that they're retained in a safe way. The other thing you want to do is try and obfuscate at source, which sounds really easy. Take the data set out of wherever it's stored and have it immediately safe in the anonymized form. This is actually very difficult, because if you're dealing with quantities of data of any decent size, or you're, it's in a protected environment, you probably just can't rock up with a laptop, apply your transformations and take it out. There's going to be some sort of pipeline, some sort of interface, and often that ends up being, something that's connected, export, and then there's a stage in between. So that means whoever's doing this, if you're a researcher or a data scientist or whatever, you become a target because you have all this valuable original data in the same place where you can run a load of code to transform it. So this is what we're looking to try and achieve. If you're a blue teamer, some representative useful data sets where you've minimized the likelihood of its use. There is code for all these things. If you're curious, that will run in Jupyter Notebooks or on Google Colab. If you're a blue teamer, maybe this is some ideas for detections, or if not detections, because this sort of logic can be quite noisy, maybe for ranking things if you're mid-investigation. If you're a red teamer, maybe it's some ideas for how to be sneaky, or perhaps more likely, just how to make a lot of noise and do something else over the side. And that's it. Any questions? Yes?
Obviously, the issue is extraction of data from organizations. What advice would you give to people that have got big data sets about managing them so that in the event of extraction, they don't become much of an issue when they get done?
So I guess there's a lot of stuff. So there's the sharing part, which is basically get advice from people who've either done it before, and or the people who are legally in charge of assuring that data. In terms of practically managing the data within your own environment, the main thing is just to keep what you need, and that will be dependent on whatever your business context is. You can set up various parts of, transforms, but again, it comes down to keeping what you need. And sometimes it will be the simple version of this, which is just get rid of it. And sometimes it will be worth transforming it. Because if you've got people that want a data set to be usable, it needs to look like a real record. It needs to look like a real person because they're testing a system. And they want to make sure that works. So the interesting thing for data scientists is they need to sit between the two. So your developers, in theory, can have an entirely fake data set, as long as it's within the normal boundaries of what is in the real data set. So your production data can be completely separate. When you've got data scientists, if they're trying to get, for example, machine learning algorithms to learn features from data, you need the real data. So you've got this really awkward scenario where you've got live code, potentially hands-on keyboard, if you've not got some sort of CI/CD system set up, where you've got code and live data in the same place. And then it's about how you manage the risk of doing that. Yes.
I find that risk acceptance seems to be the way forward. Because I'm find that services, when you turn around to an developer and say, I'm sorry, you need to go away and work on a bit of scripting here to normalize our rules. Thou shalt never put any production into live data to test the environment. It's too hard to do. Let's just fuck it up. We'll do it for 2 weeks.
That's certainly one way. I've fought many of these battles. There's different ways you can get around it. Ideally, if you're going to be doing this on an ongoing basis, you want to be able to support the use case for data scientists, i.e. coder and data. And yeah, it's always going to be risk acceptance because everything is risk acceptance. But having a proper environment for that, where everything is decided beforehand and put through a proper project rather than just doing it for 2 weeks and then a year from now we'll also just do it for 2 weeks. It's one of those type of decisions, right?
I just want to go a little bit more relaxed now. Commercial products, decision for it rather than students, scientists, so I can develop obfuscation to fit your systems.
So there are obfuscation products, and yes, they will help avoid that. The problem is you probably want a data scientist or someone who knows the data, whatever their job title is, in to make the decisions about which relationships are being broken, because it's very difficult. Well, the tool can't know that. Maybe consultants who have worked on similar data can help, but you do really need someone who knows its data set and what they're going to try and do with it after it's obfuscated.
I really like the example of favourite colours and say, we just generate some colours from massive colour data to do that. So that kind of thing, obviously, it's fixed. You can say, like, choose from the 10 primary colours. Even that would be too basic. You choose more.
So you can.
So to understand how to merge that data, you've got to get close to the business. But then you don't be too close to the business, so you lose objectivity of this. So it's definitely hard to know.
So
when you combine data sets, so you've got this one says they're blue and this one says they're green. And then you look at the two and go, well, they have the same colour.
Yeah.
So therefore, there's something wrong here.
That's what I say about relationships.
That would be consistent across the different databases, and even databases for that user, they don't choose the same colours.
So I didn't note it on the slide, but this default dictionary is what stores the mapping between the original colour or name or whatever and the replaced version. So if you're doing it one way, you just throw that dictionary away after you've done the conversion. If you want to keep it for use on a different data set that needs the same transform, you can keep it around somewhere safe if you want. And it's just the mapping between the two. On the colours thing, you could try and use more sensible colours so you don't get stupid Dulux paint stuff, but then you're restricting your input. So when someone in the real world does say something weird, like tangerine, it's going to run out of colours.
But that transforms would be on the developer's laptop in a notepad file. So you get his note, you get his laptop, and then you've got it transformed and you can be working back.
Yep, if you save it.
Should be saving what the age. What's got the policy suggested stuff through laptop? Security control just counts out risk balance.
So, I mean, it doesn't have to be done. It's done in Python, so you can do that where you want.
From the network, you've got data, and you've got the transformers on top. It's two separate locations.
Right, thank you very much.
Thank you.